Good afternoon, and welcome to today's webinar on Resilient PNT, the European Perspective, hosted by Orolia. My name is John Fisher. I'm the VP of Advanced R&D at Orolia, and today we are very fortunate to be joined by 5 other excellent speakers. First up will be Gerhard Beretz. He's Senior Expert Navigation Systems Radio Spectrum Coordinator at EUROCONTROL. Next will be Flavio Spardadelli, Marketing Development Technology Officer at the European GNSS-Space Agency, or GSA. Followed by Jean-Arnold Chenillot, Senior Program Manager at Orolia Systems and Solutions, which we affectionately call O2S here. Next, we'll have Mike O'Connor, CEO of Satelles, and then we will also hear from Ganesh Pattabiraman, CEO of NextNav. So before we get started, we have a few housekeeping things to take. This webinar is being recorded for those of you who are unable to join with us live today. Of course, you can't hear that because you're not with us yet, but maybe if you listen to the recording, you will. We encourage you to submit any questions you have during the meeting in the box shown there on the screen, and we're going to try to address some of those at the end of the meeting, or maybe even after. And if for some reason you lose connection to the meeting, you can join again using the same meeting link. So we have a full slate today of presentations in a very limited time to do that, so we're going to try to get a lot of information in at once. First up, Gary Beretz will tell us about an overview of the threats to GNSS and how they're being addressed in the aviation world, followed by Flavio Spardadelli, who will give us the GSA perspective on countermeasures, and then Jean-Arnold Chenillot will share with us a project his team at Orolia is working on in the area of critical timing. Then we'll hear from both Mike O'Connor and Ganesh Pattabiraman with an introduction of this newly formed Open PNT Industry Alliance. And then lastly, we'll finish up with questions and answers from the audience, hopefully if we have time. So since we've got a lot to get through, we will get started. But before I turn it over to Gary, we do have a quick poll question we would like you to answer. So there it is, it's popped up. Have you or your organization ever experienced GNSS outages from jamming or spoofing? So please select just one of these, either yes, I've just only experienced jamming, yes, just spoofing, or yes, both jamming and spoofing, or no, neither, or maybe you don't know. So if you can, please respond to this, or as Jimi Hendrix would say, are you experienced? Have you experienced any of these things? So I don't know if we may give a little music that would go along with this, if I had some Jimi Hendrix music, but I think as you guys answer, we should see some results soon. And yes, there are the results. So yes, jamming more than spoofing, but yes, I guess both jamming and spoofing. We have, geez, almost, what is that? Almost 40% of both jamming and spoofing. So about half the audience having experienced both either jamming or spoofing, about a third not, and about a quarter that says they don't know. And that's a real important point, is that that's part of the whole interference detection thing, is just even knowing that you're being interfered with. So great. So without any more of that, Gary, I'll turn it over to you and hear your presentation.
Yes. Hello, John and everybody. Do you hear me okay?
Yes, we hear you great. Thank you.
Excellent. So, yeah. So some of you may not be aware that we have just completed a major milestone in aviation. So actually it was in 2001 when the first GNSS standards were introduced in ICAO Annex 10, which contains the standard and recommended practices for global use of satellite navigation. Just this November, the ICAO, the International Civil Aviation Organization's nav systems panel, approved new standards for Galileo, for GPS L5, GLONASS CDMA, and the Beidou system. So that's been a major milestone for us in actually moving towards a robust multi-constellation environment. What is really fantastic about GNSS is that it can handle a lot of things. The buzzword with the COVID crisis that has hit aviation hard is that it's scalable. So whereas last year, 2019, we were worrying about how to increase capacity to accommodate more and more aircraft, that is not a problem that we have this year, unfortunately. But it also serves well to actually reduce environmental impact of flights, to actually enable aircraft to fly ideal trajectories, and that is reflected both in the performance-based navigation implementing rule in Europe that ensures that vertically guided approaches are available to all instrument runway ends, and to also the surveillance side of things, which has made mandatory automatic dependent surveillance broadcasts, so where the aircraft broadcasts its GPS position, that both of these enable advanced navigation and surveillance capability. The other thing that is a bit unique and a bit of an unknown, uncharted territory is that actually any manufacturer is free to use GNSS as they choose, both in the aircraft and in ground CNS air and air traffic management systems. And so in some cases becoming difficult to tell what exactly will not work when GPS is not there, and to know exactly also what happens in the transition between GPS being there and GPS not being there. Just to give you a bit of an appreciation maybe of what Eurocontrol does. So one of our functions is the network management function to actually organize traffic flows in Europe, to make sure that no given sector that is handled by a given air traffic controller all of a sudden receives too many aircraft at the same time. And so what we need for that is, of course, visibility of traffic. And the more that we see that, especially with traffic coming into the European network, the better we can plan that, of course. And so we have the inner blue network manager area, and then a 1 hour circle around that, and a 6 hour ring even on top of that. And we have an agreement with Arean, which is space-based ADS-B, so our satellites are receiving the aircraft's position reports. And you can see there are many things that can be done with that data. That is really bringing big data to aviation. That is bringing data intelligence to aviation. And of course, for actually managing aircraft in a sense that operations are smooth and that airplanes don't wait in the air unnecessarily and such, many good things can be done with that. And that said, of course, when GPS data is not available, we don't like it. Which is why we've looked into reporting from pilots, because one of the things that is tricky is that you actually need to find out about it. And what we found is that reporting streams go all over the place. People don't necessarily know whom to tell. So we've made an effort to align that. And unfortunately, after some increase in 2016, that already worried us a bit. 2018 and 19 have been top years in terms of getting, on the average, 10 GPS reports daily. Now, it's important to know that these are reports by pilots saying that their GPS is out, and it's of course not their job to analyze whether this is due to interference, but we then do a due diligence process where we make sure that, oh, was there a problem with the constellation or with the ionosphere and such? The conclusion is then usually that it is most likely RFI. In 2020, this trend continues, so it scales, unfortunately. So the number of reports is, of course, down because there are less flights, but there still are reports. It's the Black Sea, Caspian Sea regions that are affected. It's the Mediterranean Sea, the Eastern Mediterranean Sea, Cyprus and Malta airspace. And it's also some of the cross-polar routes going through Norway, Finland, affecting flights between the Middle East and Canada and USA. That said, it's not a Middle Eastern problem only. Of course, impacts happen also during other phases, but surprisingly, the most common events are during the en route phase, and that is really something a bit concerning because these are aircraft that are flying at 30,000 feet, so about 10 kilometers altitude over significant distances. So that means there's some really serious interference going on. When a specific area is affected a lot, then we launch an investigation, and you see here a flight that was conducted by DLR, the German Aerospace Research Center, using an Airbus A320 in CYPRUS airspace. You see on the left the trajectory that they've flown, and on the right, the time during which the GPS signal was available. And you can see that it's not a good day on that day, 13 February 2020, to fly and try and fly on GPS. And it shows very clearly that, unfortunately, the GPS environment in some places of the world is not so friendly. We have pilot reports that are subject to confidentiality, so we cannot really disclose locations. But what we can say is that what we see in the aviation sector actually matches up quite well with what is being seen in the maritime sector. So there have been other reports about the maritime sector, and so there's pretty good agreement on that. Which is why we published in one of the ICAO manuals, the GNSS manual, mitigation plan to see what we can do about that. It's a 3-step process that starts with monitoring the threat. So you've seen the data that does that. Then assess the risks. So we look at the operations, we look at alternate navigation and surveillance capabilities. And then if there are steps necessary to try and ensure the operations, we of course deploy mitigation measures. Putting up mitigation barriers, of course, you shouldn't forget the easy things you can do, such as educate people and enforce the jamming from happening. But if it does happen, you have onboard resilience that helps you, where resilient PNT capabilities help. And if it does happen to you and you're impacted, you need to make sure that you have alternate capabilities that help you to overcome and deal with the threat that you are subject to. And a person much more famous than me, Brad Parkinson, has actually called this to protect, toughen, and augment, and I think that maps quite nicely. So some of the mitigation measures that we've developed is we looked at track data from ADS-B, and you see here outages over the Eastern Mediterranean. And this is actually providing a bit of a signature of where the radio frequency interference is coming from. So with that, we can construct a heat map that actually says where is the probable location of interference. So this is the same 3-hour window than the DLR flight. And you can see over Beirut, maybe a bit over Syrian territory, and also possibly a moving source in the middle of the Eastern Mediterranean. And that means, because somehow, at least in the personal privacy side, people think that if they put a jammer, you can't be seen. No, but if you emit a signal, you can be seen. And so we are working towards actually seeing where these problems are occurring so that we can try and take appropriate action. On the operational side, we of course look, okay, what is our challenge here? We look at the trajectories going through these affected zones. Most of the aircraft are equipped with inertial navigation. There's alternate terrestrial navigation. And so it's typically only 1 or 2 flights that are subject to, that need help from ATC to navigate. And if we have surveillance coverage, that means even that flight is okay because an air traffic controller can easily look after that flight. So this is the operational risk assessment that takes the full system in the conclusion. So just to wrap up of what this means for PNT, number one, don't forget that you can do a lot of mitigation without technology, outreach, information, etc. Then we have, started with GNSS as an add-on to our terrestrial navigation infrastructure. It's now sort of flip-flopped in the sense that GPS has become primary, with soon, of course, multi-constellation GNSS being primary. And then what used to be primary before, as in the terrestrial nav aids, are now really our complementary PNT technology. What we're working on is actually to try and get the aircraft receiver to detect the RFI and downlink that to ATC directly so that we can judge both operational impact and geolocate the sources effectively. And of course, robust single frequency modes will also help with aviation being less affected by this interference. We keep our eyes open for fancy new tech. There are limits of what can be installed on an air transport aircraft that is subject to safety and certification, etc., that is operating in a harsh temperature environment, etc. But there is, of course, also communications, navigation, surveillance infrastructure on the ground. And there are special platforms, flight inspection aircraft, low Earth orbit satellites that also provide very interesting capabilities. So with that, we try to move towards integrated CNS, which is really not about putting all your eggs in the one basket, but actually to try and overcome common mode problems with flexible, scalable, and cost-effective combinations of different solutions. So with that, I think I'm well at the limit of my time. So I basically just have to thank all the various persons that helped me with this. I have a bit of further reading in case you are interested. And with that, can hand over to the next speaker, Flavio. Thank you very much for your attention.
Thank you, Gary. That was great. I think I'm going to feel safer when we finally start flying again, knowing that a lot of those measures are being taken care of, and that in fact you are mapping where the interference is coming from. They always say to address any problem, you first need to know about it, understand it, and we've been using the term GNSS weather reporting, and I think that's going to start happening here, that we treat it like weather, that interference, and that is almost like bad weather. So before we turn it over to Flavio, we have another poll question. So if we could put up that, the question is, do you have issues or restrictions from using GNSS constellations that are foreign to your country? So that's just an important thing. As Gary had said, we're kind of flip-flopping some things of where everyone used to just use GPS, but now we have all these great other systems, and so instead of now you don't have to depend on GPS in your particular country, but do you have other restrictions now, or is there a certain reason why you can't? So we'll wait for the results, and it looks like they're coming up. And so yes, we seem to have about a quarter of the folks do have a restriction, about 40% don't, and another third doesn't really know. So okay, that's interesting. I really didn't know what to expect for this this answer, but that's kind of good to understand. So okay, Flavio, we'll turn it over to you and let you begin your presentation.
Thank you, John. Hope that you can hear me loud and clear.
Yes, we hear you great.
So good morning or good afternoon, everyone. Let me see if it works. Okay, so here we are. So let me start by saying that as we know, it is a fact that nowadays GNSS is actually used for several types of applications. And let me start by sharing some figures here. So according to the GSA GNSS market report, which I suggest you to look at in case you didn't so far, in 2019, the number of GNSS devices in use was about 6.5 billion, expected to exceed the 10 billion in 10 years' time. And almost 2 billions of these devices were actually sold last year. And these numbers actually correspond to a total revenues value of over 150 billion today, to become more than double in the same time frame, including services. Now, associated to this number, which I believe that are quite impressive in terms of absolute devices that are used across the globe, we have actually observed a clear trend, which is related to the fact that there is more and more an increased usage of GNSS in applications where liability or even safety are concerned. And this is also beyond the traditional cases such as aviation, which was just presented. Indeed, today GNSS is actually used is widely used, let me say, in application like drones navigation, automated driving functions, logistics, as well as timing and synchronization of critical infrastructure and many other. And these applications, and most important, the users of these applications, must rely obviously on trustable positioning and timing. However, as we all know, any technology, and this applies also to GNSS, actually comes with some vulnerabilities. And for GNSS, these vulnerabilities have clear names: spoofing and jamming. And when such events occur, when a spoofing or a jamming event actually occur, the GNSS PVT solution might be actually either degraded or even become unavailable in case of denial of service. And this, of course, is not really suitable for these sensitive applications. So for this reason, any technology which actually contribute to the PNT solution, especially for these applications that are quite sensitive in that respect, have to consider some countermeasures to mitigate both the likelihood of occurrence of such events and the actual impact of these events on the final application. And when it comes to spoofing, GNSS countermeasure is called authentication. And since GNSS signals have two components, namely the range, which is the measured measured distance between the receiver antenna and the satellite that is transmitting, and the data, the navigation message, both of these components of GNSS have to be actually protected. But unfortunately, this might not be enough, because in most of the cases, applications today they have to rely on seamless PNT under any condition. And this is only possible if those PNT-based applications can rely on a set of complementary technologies or techniques that are fused together to compute the ultimate PNT solution. And this approach typically brings multiple benefits. One of them, indeed, being the capability to explore the technology diversity, so the different components working together and contributing from different perspectives on the same ultimate objective, which kind of complementing GNSS can actually be able to kind of overcome the GNSS limitation when they occur. Now, as you might know, among other responsibilities, the GSA is actually, the European GNSS Agency is actually in charge of the service provision for the so-called European GNSS. So the two programs, EGNOS and Galileo. And concerning the built-in anti-spoofing capability that is offered by Galileo, here you have kind of a pretty complete overview of what the concerned services are about. And you see here that in order of complexity, which has to be kind of commensurate to the expected application exposure to the actual threat, to the actual spoofing threat, we have three services. And actually, the rule is that the higher the spoofing risk, the more robust the required service. Okay, the Galileo is able to offer 3 levels of protection, following kind of a stepwise approach. The first one being the open service navigation message authentication, which is a pretty simple to integrate capability that is compatible with any receiver being them consumer grade or highly professional receiver. It's a capability which is delivered over the first frequency, E1B. So in principle, it is available to all receivers that are able, also the single frequency ones, that are able to process E1 bandwidth. And the objective of this service is to actually offer data authentication. So I was saying before that GNSS has two components. Both of them have to be protected. OSNMA has the objective to protect the data component, the navigation message, okay? Navigation message authentication. And this is done through an asymmetric encryption protocol, which has the advantage that does not bring any need to handle security kind of secret keys. Okay, so it's pretty simple from operational viewpoint to be kind of implemented also from operational viewpoint in any kind of receiver. Now, the second service which is offered by Galileo is the so-called commercial authentication service, CAS, which kind of complements OSNMA by offering range authentication through the third frequency, E6. This is a service which somehow relies on symmetric encryption based on private key and has to be intended as a kind of step 2 to complement OSNMA and protect the full range of component of GNSS. To complete the picture, Galileo also includes in the suite of in kind of the portfolio of services include a third service which is called public regulated service, which is set to offer the highest level of service continuity and authentication for specific users. And these specific users are governmentally authorized users. So it's a service which is on purpose designed to offer high degree of protection for very specific governmental users. Now here you can see a successful example of OSNMA implementation. This is a project which is actually funded by the GSA, and it has the aim to demonstrate the OSNMA suitability and benefits, most important for a very specific use case, which is the smart tachograph. Now, the smart tachograph, for those of you who are not familiar with this specific application, is a regulated application, which in Europe is set to kind of monitor and record the driving and resting times for truck drivers. So it is a typical application which is meant to increase the safety on roads. And since the specific peculiarity of this application, it is a typical case of application exposed to self-spoofing risk. So in this case, it is the user itself who might have the interest to somehow deceive the receiver, the GNSS receiver. Now, this project was extremely important for us. It was instrumental for us to demonstrate, first of all, that OSNMA is a functionality, quite advanced functionality, innovative functionality, which is compatible with the commercial grade receiver. And in particular, this project has prototyped OSNMA in the TSO5 by ST Microelectronics, which is a commercial grade receiver designed for automotive applications. And it was also able to demonstrate that OSNMA, together with additional receiver-based anti-spoofing techniques, is actually able to considerably reduce the spoofing risk. To complete the picture from a different viewpoint, here you have two additional projects, again funded by the GSA, which are currently implementing OSNMA in receivers, in applications that are a bit more high grade. These are applications that are meant to kind of validate the concept of OSNMA in timing and synchronization services for energy, finance, and communication networks. Two consortia are working on kind of two sister projects. One of them is particularly relevant for our Orolia friends today, because it is also participated by Orolia, who is actually providing the receiver to demonstrate the OSNMA benefit in gears. And the parallel project is actually participated and is actually implemented under the lead of Thales Alenia Space. Now, both projects somehow had the ambition to demonstrate resilience of PNT for timing and synchronization, kind of merging anti-spoofing and anti-jamming techniques for this specific target. And both of them aimed at kind of achieving anti-spoofing and anti-jamming by means of exploiting a number of differentiators, a number of elements, including multi-frequency, multi-constellation, which we consider extremely important, OSNMA, as I was saying, and specific interference detection and mitigation techniques. Now, that being said, let me speak a bit more on interference. Now, so far I was focusing mainly on spoofing because in Europe, in the European GNSS program, and specifically in Galileo, we have really built-in services, built-in functionality that are designed to cope with the spoofing. Now, for jamming, let me start by explaining a bit of context. We have funded a time ago a project which is named Strike 3. And this project was extremely important because it actually demonstrated that radio frequency interference in L-band, which is the band used by GNSS systems, is pretty common. And I have to say that it is more common than expected. Through a monitoring network composed of over 50 sites in more than 20 countries, across the globe, so it was not kind of a European project, it was kind of a monitoring across the globe. The project, so this consortium was able to detect and create a very large database of radio frequency threat signatures. The good fact here is that likely the vast majority of those RF threats resulted to be unintentional. So they are not attacks, they are unintentional interference, which nevertheless can provoke really serious problems. And another good factor is that only a minor, let's say a limited share of these detected interference was considered to be able to actually affect the functionality of the receiver. Nevertheless, it confirmed that the jamming threat is quite concrete. So I need to convene with the colleague of Eurocontrol that jamming is an actual threat, is a problem that is extremely concrete and actual. From a GNSS perspective, I have to say that conversely to what we said for spoofing, when it comes to jamming, there is no specific countermeasure which is able to avoid the degradation of or serving denial against any type of jamming. However, I think that it's reasonable to say that when it comes to narrowband interference, certainly there are a number of elements which are advantageous from this point of view. And specifically, frequency diversity is certainly one element. So in case of narrowband interference, having the capability to switch from one frequency to another, hoping that the other frequency is clean, so it's not affected by jamming, is for sure one option. Okay, and in Galileo, to say that the Galileo services are offered over 3 frequencies, so there are 3 options there. Second option, which is still an alternative when it comes to narrowband interference, is to make good use of wideband signals. And in Galileo, over frequency E5, we have an extremely wideband signal, more than 50 megahertz signal, which is called E5 ALBOC. But again, once again, in the same way we somehow got to this conclusion for spoofing threats, the same also applies to jamming. And when it comes to this kind of spoofing, the ultimate solution is sensor fusion. So kind of a wise usage of GNSS together with the complementary technology. And indeed, I have to say that in our opinion, when it comes to applications that require high level of trust under any condition, so high level of trust in any condition, in any scenario, the recommendation is to build on sensor fusion. And sensor fusion is nothing else than a big filter that should include, first of all, GNSS, which is recognized to be as a key element for its unique capability to provide global, absolute, and accurate positioning and timing. But at the same time, GNSS has to be complemented with alternative technology, which is able to cover GNSS when there are outages or performance degradation. Now, with this, I conclude my presentation and give back the floor to you, John. Thank you very much.
Thank you, Flavio. That was fascinating. I think I learned quite a bit there. It was encouraging to see that most of the interference is unintentional, but also it was nice to see that there are a number of countermeasures, especially the new multi-frequency L5, E5 band. So we'll transition to our next speaker, Jean-Arnold, but first we have a quick poll. What is your primary use of GNSS? Is it positioning, navigation, or timing, or any 2 or 3 of those? So if you could just quickly select one of those choices, and we'll try to get an idea of where people are using things. So, and we should have some music while we wait, but you probably don't want to hear me sing, so we won't do that at all. Should have this. There's a pretty simple question. We should have some results, and we do. So it looks like we do have a few people that are just timing only. I guess maybe about a fifth of the people timing only. About a tenth are navigation and positioning, but most are using it for the multiple purposes. Okay.
Hi, everybody. It looks like John's audio has gone out a little bit, so we're going to turn the presentation over to Jean-Arnold now.
Hello, good afternoon, good morning, good day to everyone. Jean-Arnold Chenier from Orolia 2S, the special division from Orolia in charge of the special project and European projects. So today we are talking about gears that was presented a few moments ago by Flavio. So we go a bit deeper into this project. Really, the necessity here is to create a timing receiver for critical infrastructures and for the markets that are being shown on the picture on the right. So energy, finance, communication, transportation, and utilities. We have a need, and I think I won't stress it too much because it has been demonstrated by the other speaker before. There is a growing need for resilience for the critical infrastructure, and that's the source of this project. It is really to protect those critical infrastructure and critical markets from the GNSS threats, and that's why the EU wanted to grant two projects, and GEARS is one of those two to develop such a timing receiver. Yeah, and this is not really available at the moment, and we are working to make it available very soon. So the GEARS project, GEARS initiative, it's the Galileo authenticated robust timing system solution, and it's developing a timing receiver for the critical infrastructure based on the OS and EMA messages from Galileo, but we went a bit further than that, and we added some additional what we call IDM, interference detection and mitigation techniques on top of the OS and EMA. So we try to work closely with the communities and the industries we are working for. So we get the feedback from the users, and we are looking into getting the receiver validated by those industries as well, to ensure that we are not creating just yet another receiver, but we are creating a clock that is that corresponds to the need of the market. So we are leading the project, but we are not alone. We are working with the NAVCERT, the NLS, the Finnish Geospatial Research Institute, FDC, another French company, and NLR in the Netherlands. So we are a true European project working on this matter. Our three objectives. First one is to do exactly the same performance. We don't want to be we don't want to be worse than anything on the market. So we need to achieve the target of below 50 nanoseconds to the UTC synchronization. And on top of that, we are using RAIM as an example, but we are using monitoring algorithms to ensure the integrity of the signals. And one of the key objective also is to avoid any calibration of the system. We don't want any painful calibration steps when we set up the system. So that's one of the main objectives. The second one is really to develop and demonstrate the OSNMA service to the operators, to the critical infrastructures, to demonstrate that this is a tool that they must use in order to protect their timing networks and timing distribution systems. And lastly, we are working also on standardization activities to define resiliency tests and to define standards for the market, so that there are some rules that exist to validate a product in the future against some standards. I said we went a bit further than just OSNMA. We are also working in this project on the CRP antenna. So CRP antenna means that we are working with an array of 4 antennas. You can see a 3D model on the right hand side of the screen. It is called GUARD, and the idea here is to use multiple antennas to be able to null some part of the radiation that we receive, so that if there is a source of jamming from or spoofing from a specific location, we can detect it and we can null it, so that the rest of the antennas won't be affected by it, and we can keep on receiving the signal, because the best resilience is still to get the true signal from the sky. So if we can do that using an antenna and try to mask any jamming signal or spoofing signal, intentional or non-intentional, coming from any direction, that's a nice step. The second one is within the receiver. We talked about OSNMA already, but there is also additional step. We are multi-constellations and we are multi-frequency, working on Galileo, but not only, on other GNSS constellations. Plus, we are integrating the new quick correction for the correction of ionospheric errors within the receiver. The receiver is based on a TZ05 that is modified to be able to run all those signals and especially OSNMA. And lastly, we are developing a full clock, so a fully redundant timing system. Not just the receiver, so capable of getting multiple inputs and multiple outputs as well, capable of synchronizing itself with another clock on the network, not only using GNSS, as Flavio said. One key of the resilience is to be capable of using different sources, and that's one of the target of this project as well. So once again, about the antenna, we are really sure that the null forming is something essential to be able to remove different sources of interference. With 4 elements CRPA, you are capable of removing a maximum of 3 simultaneous sources. If the 4 elements are affected, you need to switch back to some backups, either the internal oscillator or another source of synchronization, your cesium in the lab, or another clock somewhere on the network. Next, we have the OSNMA for the integrity, for checking that the signal that we are receiving is the right one and not a spoofed one. And plus the RAIM implementation, we are checking the different satellites and checking the coherence between the signal we get from those satellites to once again to detect spoofing and or to detect outliers within the bunch of satellites that we are receiving at any time. And lastly, we are focusing on the ease of use, the absence of calibration, the fact that we are a full master and slave PTP clock for your network, working with the GNSS receiver, and we are also developing some additional features. The fact that we can send over the GNSS signal over Ethernet and not only over RF signal. We know from our users that it's sometimes a bit painful to drive a cable within the data center. Sometimes Ethernet network or fiber is easier access or easier to run than a rigid and heavy RF cable. So that's also adding to the ease of use. And lastly, we have the option of running off power over Ethernet to avoid bringing too many power supplies to the clock. The last focus is on the IGM receiver itself. We are doing some techniques to filter out the jamming inside the receiver if we are using a standard antenna, for instance. So with the help of some frequency filtering algorithm, we are able to filter out the 5 main types of jamming: the wide sweep, multiple narrowband, triangular, thick, and simple CW directly within the receiver. So in case we are not using the guard antenna. And as mentioned earlier, we are supporting Galileo as well as the other constellation on up to 3 frequency bands. So you will see the board a bit now on the right. It's a dual receiver, so that we are capable of using those 3 frequencies and selecting any of the any constellation you want, and avoiding the receiver to make itself the calculation for the PVT on multi-constellation. Here we have each receiver working on a particular constellation, getting the PVT out on this constellation, and no black magic to make a PVT calculation based on satellites coming from different constellations. And lastly, it will be integrated in the GEARS project. It can be integrated in other clocks from our portfolio, and we work with the guard antenna, but also with simple antennas or complex antenna that send the GNSS signal digitalized directly to the receiver, not in a RF fashion. So that's it for me. Thank you.
Very good. Thank you, Jean-Arnold. That was good. It's interesting. I see the common theme from all of the three presentations here about just all the multi-layer, multiple, diverse ways of combating interference and spoofing, and I think that was great. So let's go on then to our next speaker. We have Mike O'Connor and Ganesh Pattabiraman to tell us about the Open PNT Industry Alliance. And so, Mike, I'll turn it over to you, and I will advance the slides for you at this point.
Excellent. Thank you, John. And thanks for great presentations today. And hello, everyone. So my name is Mike O'Connor. I'm the CEO of Satelles. We provide a secure global time and location capability using low Earth orbit satellites. So Satelles, Orolia, NextNav, and a host of other companies are pleased to announce the formation of the Open PNT Industry Alliance. As I'm sure this audience knows, nations around the world are facing an important problem. The critical infrastructure that our society relies on, including wireless communication networks, financial markets, and transportation systems, as you've heard today, are becoming increasingly reliant on GPS and GNSS for both positioning and time synchronization. But unfortunately, this reliance means that these systems are now vulnerable to attacks and other disruptions, again, also as we heard a lot about today. The issue is that, of course, these threats need to be addressed to ensure the security for everyone. So the Open PNT Industry Alliance was created to strengthen both economic and national security by supporting government efforts to accelerate the implementation of the types of backup, position, navigation, and timing capabilities that you've heard about today, and particularly for critical infrastructure applications. So our mission is to promote open market concepts that preserve industry's long-term ability to harness its collective ingenuity to protect GPS and GNSS with multiple solutions. So you'll see our members include companies with a variety of technologies, and ultimately we believe multiple solutions that are technologically advanced, that are commercially viable, and that are based on sustainable long-term funding framework are all necessary for us all to be successful. So with that, I'd love to turn it over to Ganesh Pattabiraman from NextNav to talk about some of the key aims of the Alliance and its current membership. Okay, Ganesh, are you there?
Hello. Can you folks hear me
We
now?
can hear you now. We hear you
Okay,
now, Ganesh.
Perfect. Sorry, I'm on two different communication media. Hello, everyone. I'm Ganesh Pattabiraman, CEO of NextNav. We are a terrestrially based 3D position navigation timing solution provider based out of the US. And we provide resilient position navigation timing in the absence of GPS in the urban areas. I'm very excited to be here and part of this discussion. As the various speakers have outlined, the challenges of PNT. We all love to use PNT, but it obviously has a number of vulnerabilities. And it's great to see the various steps companies are taking to mitigate the issues around PNT resilience. We feel we have a role to play in that in that solution set, and we formed the Open PNT Alliance along with Satelles and Orolia, and to essentially foster this capability, because this is now, I think we all recognize, is a growing problem. So as part of the Open PNT Alliance, we have a number of key aims, starting with fundamentally ensuring that governments recognize that this is a problem and critical infrastructure in the countries need to be protected. And so one of the aims is to work with the governments to help them understand the issues and help determine appropriate policies as we see this growing need worldwide. We also want to ensure critical infrastructures have the freedom to choose whatever technology makes sense for them. There are obviously multiple technologies, as you see here. It's not every day that competitors come together, but we all recognize that it's for the greater good. From that perspective, there's PNT, there's Satelles, NextNav. There's a whole bunch of solutions that we believe that can mitigate these problems. And finally, for this to become real, we think it's important for governments to ensure a policy framework that ensures the long-term sustainability of these systems, because fundamentally, as we all know, GNSS systems are provided free of charge. And in order to make these systems viable, there has to be some sort of an equivalent framework to enable those kinds of capabilities to ensure the long-term sustainability of these solutions. So the Alliance was launched on December 3rd, so not too long ago, and we already have over 10 companies signed up. We would invite you all to sign up, learn more about the Alliance, and sign up at the website that's listed down below, the openpnt.org. And we look forward to working with you all to enable resilient PNT available on a worldwide basis. With that, I will end my comments. Thank you.
Great. Thank you, Ganesh. Thank you, Mike. Very good. We've already had a number of questions already coming in asking how can they join the Alliance. So if I heard you right, I think you said if they go to your website right here, the openpnt.org website, they would be able to join it there. Is that correct?
That is correct. Yes.
Great. All right. Well, thank you, guys. And we're nearing the top of the hour. We want to get in a few questions and answers. We are a bit running out of time. Sherry, maybe I'll ask you if we could. You have one more poll question. Maybe we could do that poll question now, and then we'll go into our question and answer. Maybe we'll go a little over time. Real quick question. We won't even wait for the results, but this is just if you would like to opt in, and would you like someone from Orolia to contact you after the webinar? So go ahead and respond to that. We won't wait for the results, but this is just your opportunity to opt in if you want. We won't bother you if you say no. So now let's go to our questions in our question period. I guess since this is a European thing. We are a precise time company. We like to finish at the end of the hour, top of the hour. So drop off if you have to. But since it's a European thing, I'll do like European football, of where we will, as the referee, will go a bit over time. So I'll start with. We have a number of questions. So I'm turn this to our panelists, to Gary, Flavio, and Jean-Arnold. Got a number of questions about the Galileo OS NMA. When will it have an impact on the market? Or also asking what is the release timeline for that service? So guys, maybe Flavio, maybe you could start.
Yes, John, I can take this one actually. So let me briefly present what the OS NMA service timeline is. So actually now we are in a very, very intense phase. We are kind of finalizing the preparation for a wide public testing phase that we intend to launch next year. It will be an opportunity for all the receiver manufacturers, integrators, and end users to actually assess the benefits of this capability on the field. And we do this following our usual user-centric spirit. And in that respect, at the GSA, we will open a dedicated channel to collect any feedbacks from the market, which will be instrumental for us to confirm that, first of all, the service is well suited to fulfill the user needs. And at the same time, to get feedback that we might accommodate either in the initial service provision phase, which we start right after this public observation phase. And this is to answer your question. Or for other kind of service evolution purposes. And let me also say that I briefly touch upon this point in my presentation earlier today. In view of this testing opportunity, we have actually prepared the ground, working closely with several GNSS receiver manufacturers. And these receiver manufacturers actually cover a range of application and kind of typology of receivers, from consumer chipset vendors to professional grade receiver manufacturers. And I'm happy to say that some of them, such as Extreme Microelectronics, Setemprio, U-Blocks, but also others, have already prototyped the OSNMA algorithm in their pre-commercial products. And this, I think that will be extremely important, because these receivers will be available for this large testing opportunity. And we are certain that additional ones will actually step in and implement this capability to support this testing phase. So overall, I think that there is an important milestone ahead of us next year, where we really intend to validate the OSNMA concept on the field. And this will really help us to swiftly move on to the next service provision phase, thanks to kind of a market feedback.
Great, great. Thank you, Flavio. Is that, anyone else want to comment on that one? I think that was pretty comprehensive reply from Flavio. Okay. All right. Next question was, who do you see are the main users for the PRS service? I don't know who would like to take this one.
John, I think that this is also for me, because I'm here today representing the program.
Oh, yeah, great. Okay.
I'm in the best position to answer this question, and I will be very happy to do. So let me remind everyone that the Galileo public regulated service is an encrypted navigation service, which is designed to be more resistant to jamming and involuntary interference and spoofing. And since this is a service which is specifically designed for European governmentally authorized users, and for this I refer to European member states, European Council, Commission, etc. And access to the service is regulated by legislation. And specifically, there is a European Union Decision 1104, which actually establishes the rule to access PRS. And this decision actually, first of all, clarifies that every member states who intend to actually access PRS has somehow the duty to establish a specific function that is called competent PRS authority, that typically comes from national security authorities. And once this function is up and running, this competent PRS authority is CPA, in the respect of the relevant rules, so in respect also the regulation that is associated to the PRS, each CPA has the right to decide what are the users target for PRS. So this is the process. It's not something which is freely accessible by any user, but it's something that has to be kind of channeled through a specific function that has to be established according to a specific EU legislation. And just to complete the picture, let me say that outside of EU, since today we are discussing with the audience that represent both EU and non-EU users, when it comes to users outside of the European Union, international agreement between a third country and the European Commission has to be somehow put in place as a prerequisite to access PRS.
Okay, very good. Sounds like it's very well controlled item there. Let me continue. We have a couple questions related to ELORAN. One question: do you believe a terrestrial resilient timing network would be viable for Europe? And another question was: is ELORAN part of the European resilient PNT environment? Gary, why don't we start with you, at least from the aviation side? You have a comment on that?
Yeah, so we've seen momentum pick up a little bit in the US. What we say as aviation, because there is a bit of a complementary PNT discussion going on at the European Commission. Typically, and similarly in the US, often these efforts do not want to prescribe one favorite APNT solution for entire sectors. I'm actually one of the few people that has flown in a private aircraft using Arean in the US. So I think it's a fantastic system, and it's in a frequency band that nobody else wants to have. So it definitely has its advantages and it's very robust. But number one for aviation to use it, I think really with it being primarily targeted at the maritime sector, the maritime sector would need to embrace it first. And if they would really embrace it, then I think aviation could seriously look into using it as well. What then is on top of that for aviation is, of course, well, in the US, it's quite interesting that with the East and the West Coast, you can get continental coverage quite easy. In the US, we have waters around most of Europe, but actually achieving continental coverage across Europe is maybe not quite as easy. And it's a lot more than one single country, so that means a lot of countries, both inside the European Union and outside the European Union, actually would need to cooperate to make that happen. So as much as I love Arean technically, and recently there's been all sorts of interesting work done that shows that you can still get a lot of performance out of it by improving it with additional secondary factors and such. Politically, I see it quite challenging to get that moving ahead in Europe, unfortunately.
Yes, and I think we're seeing the same challenges here in the United States as well. We have 50 states that we need to get to agree on things to build out a network as well. But that's great. Okay, great. Let's go on to, I know I've gone into overtime. We'll try to get in a few more here. We have questions related to what are your thoughts on the use of multi-GNSS reception rather than relying just on solely on one? And what is the best combination of constellations, and which constellation is the highest accuracy? So Jean-Arnold, maybe we could start with you. I haven't heard from you. You have thoughts on this?
Yes, we have, and we have more than thoughts. We have requirements from our customer and users now. That's yes, multi-constellation is something very important to get some resilience because of some events that we have seen on different constellations. That there is no one harmed, no one not armed here. So everyone has its own issues. So yeah, having a backup from the sky, it's something very interesting. The issue that we see, and it's a requirement from the user sometimes, that they want to be able to precisely select the constellation they want to use, and they would like to know more what is being done to do the PVT calculation. That's what I mentioned a bit earlier in the GEARS presentation, is that it's always a bit black magic made by the GNSS manufacturers, and that's not always appreciated by the customer that wants and needs to know exactly where the time is or the position is coming from. So yeah, definitely it's of use, and it should be used, but we need to do it carefully, and we need to give some clarity for our users to ensure that they know where their data is actually coming from.
Yes, that makes sense. And if I understand the project you're working on, you are working in both a multi-frequency and multi-constellation environment, right? So you're using them all, right?
Yeah. Multi-frequency is another topic, but it's also needed to my understanding because of the jamming protection it gives, plus the added accuracy for mainly for positioning. But yeah, it's something that is a must have for the future PNT systems and timing systems.
Okay, great. I see that we still have a decent sized audience, so if my panelists don't mind, I'm going over time still, but I'll keep going. We have a few more good questions. The next question we have is, do you see a potential of interoperability and exchange of PNT resources among various governments in the future? And I guess I'll say that's a toss-up. Anyone like to jump and respond onto that one? I guess,
well, John,
go ahead. Great, Gary, go ahead. Thanks.
I'd just like to add that this is already happening. We have the United Nations International Committee on GNSS, which is where all the GNSS providers meet. And this is an exchange forum between, GPS, the EU with Galileo, the Russians with GLONASS, and Beidou, the Chinese, and other space nations, where they do get together and actually discuss on, how to, for example, agree on common performance standards and how to make the service centers better and things like that. So a forum like that exists in the form of the UNICG. It's managed by the United Nations Office of Outer Space Affairs, and if you go on their websites, I think you will find a lot of interesting information there.
Great, and yes, I would add to that. I would say that the fact that we're able to get, today in simple receivers, multi-constellation receivers, all in one module, is a testament to the fact that all these nations have been working together to on designing these systems and spacing the signals close enough so that you can receive them in one receiver, yet not so close that they interfere with each other. So I couldn't agree more. We hope that trend continues. These are nations that don't always cooperate on other things, but they've been very cooperative in this area. So I think I've probably gone over time over our welcome. I'd like to thank everyone involved in this thing, all of our speakers, all of the great information you've shared with us. There's we are planning. We'd like to keep going with these webinars. We think people are enjoying them, so we're going to continue on to next year on January 21st. The next one, Resilient PNT, for mission timing and synchronization. So again, you can access this on demand, look at the slides, look at the recordings. I'm going to wish everyone a happy holidays from Orolia, from all of our guests. Thank you all again, and thank you for attending. Goodbye.
Thank you, John.
Thanks very much and best wishes.
Thank you.